Hello, and welcome to this video covering a demonstration of CSIT 123, Introduction to Applied Data Analytics. As a company, and I'm going to do this in split screen just so we can kind of see the short PowerPoint along with a working demo using Excel, which is the primary tool that we use for the data analytics course. Although students are exposed to our programming for the last week or two of the course, just to see what data analysts use as their normal everyday tool. So as a company, it's key to be able to look into the future and to look at demand. This helps us come up with the supplies we need for our supply chain. It also allows us to best guess our product so we can do things like just-in-time inventory. This prevents us from having stock on hand, which is one, expensive, and two, nobody wants that old model. So once a new model comes out, you'll see that companies typically will give discounts just to get the old inventory out. So this tutorial will go through simple exponential smoothing to forecast out months. Specifically, we're going to try to come up with the demand forecast for year 4. If we look at the simple exponential smoothing, this only takes into account level. We'll build on SES to take into account level and trend, and this will be based on the Holtz trend exponential smoothing, as well as taking into account level, trend, and seasonality using the Holtz winter exponential smoothing. This tutorial just covers SES. You have to take CSIT 123 to learn how to do the Holtz trend, but I'll show you how that comes into play here. So let's say that Aunt Sue has this really great fruitcake recipe, and we can see the demand that she's had over the last 3 years. We can then take this demand and use Excel to create a scatter plot. Here we could see the slope of the line that goes up, as well as the y-intercept that starts at month 1 at roughly 139.1. So if we plot this out, we again see the slope and the intercept. But Aunt Sue wants to take this to Shark Tank, and she knows that Mark Cuban and company, they're absolutely going to want to have year 4 demand. So let's work through this year 4 demand using simple exponential smoothing. So in A2 in our sheet here, we're going to go over to the SES worksheet. We know we have 36 months. And we're going to use something called alpha, and this is going to be our smoothing parameter. And this is going to be, we're going to initially set this to 0.5. It has to be a value between 0 and 1. And what we've done to prime the pump, per se, is we've taken an average of the first year of data. So if we look at this level estimate for time 0, we said this is the average between B6 to B17, which is simply just the first year of data here. So from here, we can say that this level estimate, we're going to set our one-step forecast to this. So we simply just put equals C5 into D6. And what we can do now is we can do our forecast error, and this is simply just going to be the demand minus our one-step forecast. And then in C6, what we're going to do is we're going to use this formula that takes C5, the level estimate, applies our alpha value to that, and then multiplies that by our forecast error. Notice in this class, we'll use a lot of mixed referencing and absolute referencing in Excel, and this will allow us to rapidly use autofill. So I'm just going to put this in here. And then now we could just simply come down to month 36. And this gives us our demand right here. Let's see, something didn't go right here. So let's see, we have C5 plus C2 times E6. Because we didn't, so we actually have to autofill all of these down. And now when we do this, now everything will come into place. And here we go. We can see that our level estimate at the end is 271 using our using our one-step forecast and our forecast error coming through all of the months. Now notice starting at B42, since we only have level, we're going to say that that is going to be equal to C41. So you're going to see that this is not a very good model in the fact that it only takes into account the level constant. Again, if we look at the Holtz trend and the Holtz winters, we're actually able to account for trend as well as seasonality too. So the next thing we want to do is we want to go into F6, and we're going to take our forecast, and we're going to do the sum of the squared error here. And we're going to autofill this down to month 36. And then what we've done in cell E2 is we've taken E2 here, and that's going to be the sum of squared errors. And then we can do the standard error based on the sum of squared errors. And this is simply going to be the sum of squared errors divided by the number of months we have minus the number of features we're taking into account. And that's going to be just the alpha for this case. Now what we can do is we can go look at Solver. So perhaps students have or have not used Solver before. So this is going to be in data, and we're going to go into Solver. And what we want to do is we want to set our objective to, we're going to set our objective to F2. So what we want to do is we want to minimize our standard error. And we're going to do this by changing our variable cell C2 alpha. And we want to have this alpha less than equal to 1. And by us checking this block here of making the unconstrained variable non-negative, that forces us that to be at least 0. And now between this and the negative or less than 1, we now have gamma or alpha coming out to be something that's between 0 and 1. Because we've used squares here, we can't use the simple linear method. We'll have to use the evolutionary method. And then if we just click solve here, you can see down here at the bottom, we're just cranking through all of our objectives here. And then let's see, it'll take a second for us to end this. In actuality, let me go in and set this to a time constraint of 10 seconds. I just want to do that for this quick demo. All right, so I think let's see, I did something wrong with the constraints here. So let's go back in and check Solver. So we wanted to make this F2, and we're going to use C2. I accidentally pressed the F21. So let's go back in, and we're going to set this up for options to just have a max time of 10 seconds. And now let's solve this guy here. Okay, and you can see now that we quickly went down to our incumbent value of 20.39. And then here we go. And then now we have a new alpha that went from 0.5 up to 0.73. If we plotted this out, we can see that now our level has went from 271 down to 289. Looking at this graph, we can see that this is just a flat line because this is simple exponential smoothing only. If we wanted to, we can use the Holtz forecast to come up with trend. So this model now accounts for both level and trend. And then what we can do is use the Holtz winter, and then now we can take into account seasonality. You can see that at month 12 and at month 24 and 36 and predicted at 48, we have spikes. And we would expect this because a lot of people will give persons Aunt Sue's fruitcake during the holidays. We can further take this into a Monte Carlo scenario where we can get our bounds, and now we can do our fan charts and account for 95% of the data, which is 2 standard deviations. And then, like I said, now we have this fan chart. So now you can go out to Mark Cuban and Shark Tank, and Aunt Sue would be in really great shape to get her idea to be the next Shark Tank. So as we wrapped up, I hope you've enjoyed this video. I would love to see you guys in CSIT 123 this upcoming spring. The class is from 10:30 to 11:45 on the Oceanside campus in OC 4803. Even though there's a math prerequisite, students that have taken Math 28 or Math 30 can submit a waiver, and that should allow you to take the course. And please reach out to me or reach out to your instructor, and I'm happy to answer any questions that you have about this great and upcoming field. Thank you for watching this video.